energetic, joshful students. Welcome back to another episode of PYQ Power Play. Now, as always, we are going to solve 3, 4, or 5 questions from 2023 paper of NSEP. Now, this is not a solution series. It's not like we are just going to solve those problems. Solutions are available all over internet. So this is not just solutions here. It's more about enhancing your problem solving skills. We will learn in depth about how to think about the approach, think about what concept to use. And this is more about learning or enhancing your problem solving skills. My name is Bhavdeep Sethi, and I have been converting physics haters to physics lovers. And I always say physics को रट्टा मारोगे तो physics बुरा मान जाएगी. Nature में everywhere you will see physics. Nature is the best teacher for physics. So just look around you, discover, and you will learn a lot of concepts out there. So what you should not expect, obviously, in any of my sessions, never expect the spoon feeding part. So it's not like we are just going to solve questions. You are going to note down the steps and memorize those. No, this is not a solution series. This is where we look at the question, we learn the concepts, we enhance our problem solving skills. So if you're looking for spoon feeding, I'm really sorry to say that's not going to happen here. So first things first, the dates are out. So November 24 is our NSEP exam, 8:30 a.m. You can fill out the form right now. It's open. Please go to the website and fill it out. And there is a step-by-step guide by Nidhi ma'am on Vedantu Olympiad School where you can actually, I would say, look at that video, watch that video before even filling out this form, because this form is a little lengthy and confusing also sometimes. You might not find your city, you might not find your school. There are few things you will confused about what to fill, what not to fill. So Nidhi ma'am's video is a must-see video on this. Now, also, there are videos that I have made regarding the eligibility criteria. Very briefly, if you're in 8th and ninth, no, you can't give NSCP this year. You have to go for NSCJS. If you're in 11th and 12th, yes, NSCP is open to you. If you're in 10th, depending on your date of birth, you might have only one choice or either of them. So look for my videos on that on VOS. So exam pattern, 60 questions, 216 marks. So questions, easy, medium, difficult. You have to manage your time accordingly. Now let's dive into the first question here. Very beautiful question. So they say a figure shows a smooth tunnel AB. So they've dig a tunnel over here of length 2L in a uniform density planet, say Earth, okay, of mass m and radius r. A small ball of mass m is released from rest at end A of the tunnel. So basically, this is a spherical planet. Hypothetically, they have dig a tunnel from this point to this point, and this is dropping a ball here. So what is going to happen to that ball? Think about it. The ball is attracted by gravity to the center of the planet, right? But because of this tunnel wall, it cannot move that way, but that force has a component downwards. So think about this. So let's analyze this. So if you visualize, there's a force of gravity here, so there's a component of that force that is trying to bring it down, so it goes down. So there's a force bringing it down, but as the ball reaches here, that force is this way now, so there's a force trying to bring it up. So don't you think this is the point where the ball would be in equilibrium? This is where the force is this way, but the wall is saying, oh, don't move, don't move. So there is no vertical kind of force over there. So this looks like an equilibrium, and these forces look to me like restoring forces. So again, we are not solving this question. I could have solved it in 1 minute for you. We are not doing that. We are just analyzing situation to make our problem solving skills better. So first of all, you have to think what's happening here. There is a kind of motion which is a restoring kind of force there. So that is going to be an oscillation. Wow. So this ball is going to oscillate. But is it a simple harmonic motion? I do not know. We will have to figure that out. So let's figure that out. So let's analyze that situation here. So we have this. So how much is the force? The force here is g times mass of this planet times the mass of this object divided by radius square, the famous Newton's formula. So the force here, this way, I'm not calling this restoring force here. This is the force of gravity. that is equal to g times the mass of the planet, uppercase M, times mass of the object, this ball, this pen, whatever, divided by the radius of that planet square. So this is not the restoring force, this is the gravitational force. Now that gravitational forces, this component is the restoring force. So how much is that? So if I were to draw a line here and assume that this angle is theta, isn't that sine theta component? So that angle being theta, so the restoring force is sine theta. Wow. So now I have the restoring force. But is it simple harmonic? I do not know. Let's go more in depth. We are not solving this problem. We are trying to understand this. We'll solve it. Solving is easy. Now, sine theta, if this were theta, what is sine theta? Sine theta is opposite over hypotenuse. Hypotenuse is the radius of the planet. And opposite is this distance x. X from the equilibrium position. So if this distance is x, so I can replace this sine theta with x over r. X over r. Over r means this can become cubed here. Okay, as soon as I do that, think about this. G is the universal constant, that uppercase G never changes. Uppercase M is the mass of the planet, that is a constant. Lowercase mass is the mass of the object, that is also a constant. Constant as in during the journey it doesn't change. That's what I mean by constant. It's not like it's constant because this pen versus this mice, I mean, they are different masses. I dropped two different objects, mass is different. But I'm saying in the given situation, as this object is oscillating, the mass of that object is not changing. Neither is the radius of the planet. So isn't this the constant here? And we know if F is of this format minus kx, where k shows the direction of force towards the mean position. So if F is equal to kx, where k is a constant and x is the displacement from mean position, this means this motion is a simple harmonic. So now I know this motion is a simple harmonic, where this is the spring factor or whatever you want to call that. Okay, so if that is the case, then I know the time period. Time period is equal to 2 pi times square root of the inertia factor over the spring factor. Spring factor means whatever is that constant you plug in there. Inertia factor in the case of linear motion is mass. So there is your solution. You would say the time period of this oscillation is 2 pi square root of inertia factor, which is m, over the spring factor, which is gmm, over r cube. So r cube jumps up. Now this m can cross out this m. Now think about it, gm over r square is the gravity, lowercase g. So I can change this time period to is equal to 2 pi square root of, so if I borrow r square from this to make this gravity, I am left with 1 r over g. So wow, I have found the time period of oscillation. Now this is the beauty of the exams. As soon as we find it and we see the option there, we are tempted to say, wow, the answer is D. Eureka, I have found it. But no, that's the problem. They're saying the time taken by the ball to reach end B. Do you think this time is T? No, that's half of the time period, because time period would have been go here and then come back. But they're saying how much is the time to reach there? It is half of this number, which is pi times. So A is the answer. So do not make that mistake. Many students make this mistake. They find something and it is matching in the option. They choose it blindly. No, don't do that. Look, read the question again to see what are they asking you. Right. So what if they ask from here to here? It would be 1/4. Right. So yeah. Let's move to the next question. So a block B of mass 0.5 kilograms moving on a horizontal frictionless table at 2 meters per second. See, I like this question because the numbers are so beautifully chosen that you don't spend any time in calculation. It's more like a conceptual question where zero calculation is required. They're very beautiful numbers. We'll see how. So on a horizontal frictionless table at 2 meters per second collides with a massless pan. This is massless pan at origin O and sticks to it. So this sticks to it. The pan is connected at the end of a horizontal unstretched. So this is the natural length of the spring with a constant of 32 newtons per meter as shown in figure. After the block collides, the displacement x as a function of t of the block as a, yeah. So you just have to find the time period of that oscillation and all that. So you just have to find the equation of motion. So we know the journey starts here at equilibrium. So it will go there, come back to equilibrium, stretch this way. So this is the mean position. When the thing starts at mean position, your timer starts at mean position, you take a sine wave. So basically, first of all, you can cross out anything and a cos here. I can cross out cos here. This cos doesn't fit here, but maybe it fits because it might be a phase difference. They might I expect us to build in here. So let's keep it for now. But I know this might be eliminated, but let's not do that for now. So this sticks here, and this is massless. So when this sticks here, they go together. So this kinetic energy it has, it is going to convert into spring's potential energy. And some point down the line, all that kinetic energy is converted to potential energy and this will stop. That is the amplitude, isn't it? So think about it. The spring is at the mean position. This has some kinetic energy and it starts going there. Kinetic converting to potential, more potential, zero kinetic, full potential. That is the amplitude. So all that kinetic energy, how much kinetic energy are we talking about? Half times mass, which is half kilogram, times velocity square. Velocity is 2 times 2. Look at this. That's why I was saying this is so beautiful. It's 1 joule, right? So that's converted into half times k. K is 32 times the amplitude square, right? That's the potential energy. Half k x square, where x is going to be the full amplitude here. This being 1, this is 2, 32. So this is 16. 1 by 16 square root of that, so amplitude, so this implies amplitude is equal to 1 by 4 meters. This looks to me like the answer, but let's not jump to the conclusions, but at least we know we can cross out these two. Right, even this one crossed out, I know this is the answer, but let's still verify. Maybe yeah, at least we'll learn something on the journey. So this is the answer, we know that, but we're not solving question, we're learning the concepts here. So what comes inside sine is the omega t. So how much is omega? Omega is equal to square root of k by m. So that is equal to k. How much is k? K is 32 and m is 1 by 2. So that's what I was saying. This is so beautiful, beautifully chosen number. So this 2 jumps up, becomes 64. Omega is 8. Root of 64 is 8. So that's your answer. Okay, let's move on to the next question here, which is question number 17. Two Carnot engines are connected in series such that okay, very good question from thermodynamics, but very easy, I would say. In exam, you have to spend less than 60 seconds on this. But since we are learning concepts, we'll go through the entire concept here, but honestly, less than 60 seconds. So two Carnot heat engines are connected in series. What is series? There's an engine here, energy in, energy out. That energy out goes to another engine as energy in and then energy out. So they're connected in series such that the sink of the first engine is the heat source of the second. Efficiency of the engines are eta 1, eta 2. Net efficiency of eta of the combination is given by. Now it's very tempting to say, okay, the first engine has an efficiency of eta 1, second has eta 2. Let's say, oh, efficiency is eta 1 plus eta 2. No, that's not how the things work. Let's think conceptually here. Let's say there was an engine here. Let's forget the question. Let's talk about a little concept here. So let's say there was an engine here, or let me draw here. I'll wipe it out. I need more space, so that's an. So let's say there is an engine here. Now let's say the efficiency of this is 20%. Let's say for the sake of understanding, this is 20% efficiency. If I give, and let's say there's another engine here, and that has an efficiency of 25%. Are we saying the total efficiency is 45? No, no. Let's see why. Let's say the engine 1 receives 100 joules. So what goes out of this engine? 20% efficiency, right? So 20% efficiency, or let's increase the efficiency maybe. So let's say uh, okay. So let's say 20% efficiency. Let's keep the numbers here. So let's say this is 20% efficiency. So what will come out of this? So what will come out of this is 20 joules of useful work. Can I say the 20 joules of useful work that is coming out of this engine, right? So what happens to the rest of 80 joules? 80 joules is rejected to the cold sink, isn't it? Efficiency of 20% means 20% is the useful energy or useful work being delivered here. Rest of it was being wasted. But then they said, okay, let's do this. The sink of the first engine is the source for this. So this 80 joules goes into this. Once 80 joules goes into this, what would now happen is 25% of that comes out here. 25% of 80 joules. What is 25% of 80 joules? 20 joules comes here. And what happens to the rest of the 60 joules? That is rejected. So this is the situation. So what is happening here is, okay, 20% efficiency means 20% of energy is being used here, 80% is rejected. Then out of that, this is rejected. So what is the total efficiency? The total efficiency is 100 joules was going in, 60 joules is wasted from this entire thing. Let's talk about the entire thing. If I enclose this in a black box, to me what it looks like is I supplied 100 joules here, 60 joules is over there, 40 joules is useful work. So the efficiency is how much? 40 joules. Because I get 20 joules here, 20 joules here. Efficiency is 40%. Another way to look at it is 100 joules was going in, 60 joules was wasted. So that is my efficiency. 100 minus 60 is 40 useful work. So 40 by 100, 40%. So you see how the efficiency is not 45%. Efficiency is only 40%, not 45. So with that understanding, let's wipe this out and let's try to solve this question very easily. So let us say, so much to wipe out here. Okay. So let us say the efficiency of first one was eta 1, eta 2. So you see how 1 minus efficiency is what we are talking about as the sink. So what would be the total efficiency of the system? This would be the total efficiency of the system. So where is this coming from? This is coming from the fact how much of the energy was wasted here, then out of that how much was wasted there. But if I take as one system here, so that black box, if I'm saying how much is the efficiency of this system, if the efficiency of that system is this, wouldn't these two efficiencies have to match? So what we are saying here is the efficiency of this being eta, so wouldn't this number have to match this number? So now you do the mathematics here. I think one of these will match, C or D. You can figure out. To me, C is the answer because this will become negative. Yeah, C is your answer. Going to the next question. I like this question because question being easy, but where the students got confused is what approach should I use? I mean, is it surface tension question? Is it what question is this? So an air bubble of radius 2 millimeters at a depth of 12 meters below the surface of water. So there is an air bubble below the surface of water at a temperature of 8 degrees Celsius. So below surface of water at a depth, temperature would be lower. So there's a bubble here, it rises up. So obviously we know as it rises up, it is going to expand for two reasons. Firstly, as it rises up, the pressure decreases, right? So pressure is more below, you're squeezing it, then you rise up, so your pressure is less, so it increases. Another thing is the temperature is also increasing. So there are two things coming into play. So isn't this a very simple question where you're saying, I know the pressures, I know the temperatures, and when you're talking about radii, you're talking about the volume of it, volume of air inside. Right. So wouldn't you say, I know the gas equation, assuming air is an ideal gas, I would say P1 V1 over T1 is equal to P2 V2 over T2, because see, we are ignoring surface tension here. We are saying there was air inside that bubble. Now air would have expanded for two reasons. One is the temperature of that air has increased, so it would increase its volume, but then also pressure has decreased, so it would increase its volume, right? PV equals nRT. So as the pressure decreases, volume increases, temperature increases, that increases. So assuming P1, V1, P1 was below the surface, so how much was the pressure there? It was not H rho g. That's one mistake many students do. They say, okay, if something is at a depth of H, the pressure there is H rho g. No, it's not H rho g. It is H rho g more than what it was at the surface. So what was at the surface? At the surface, you had the atmospheric pressure. Then you have H rho g. So 12 times rho is 1000 times the gravity divided by the temperature. Now, how much was temperature? So, no, not 8, 273, that's 0.15, I'm ignoring. So, 281, so 281, that's the temperature. So, that was the original situation. So, P1 over T1, then volume 1. What is volume 1? Volume 1 is 4 by 3. No, 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 yeah, right, I forgot the brackets over there. Okay, times pi r cubed. R is 2 millimeters. Now, many times we are tempted to convert this to meters. No, you don't have to. Because if you're putting it millimeters here, millimeters cube, let it be millimeters there, those millimeters will cross out. So when you have two things comparable, you don't have to always, right? So that should be equal to P2. Now the bubble is at the surface. So it only has the atmospheric pressure, which is 10 to the power 5. Now the temperature has increased. So 273 plus 16, it has become 16, 9, 289. So you write 289 times the new volume. That I don't know. So I'll write 4 by 3 pi and some radius cube. Now obviously in this pi, 4 by 3, all these things will cancel out. And you can do the estimations over here. This is how you solve these kind of questions. Very easy question. Now if this was easy, I would request you to share this video, like the video, tell your friends about this series. And we have also started Full Physics Mastery 2025, in which we have divided the 11th and 12th syllabus into 5 modules. So module 1, 2, 3 are 11th portion. We have started this in July, August. We finished the first module. So there are 5 modules in total. So this is fourth and fifth, which is 12 syllabus, and this was 11 syllabus. So every module is priced at 2,500. So total cost was 12,500. But because we have finished this, we'll charge for 4 modules only. So 10,000 rupees is the fee. But we'll give this recording free, and you don't have to worry. You will follow. This is something you get the recording and you will follow. And if you're asking for any prerequisites, and I always say there are 3 prerequisites. One is the willingness to learn, commitment to hard work, and your Josh. If you think you're not prepared for Olympiads, don't worry. As long as you have commitment to hard work and Josh, you will do that. Now, also you can use our coupon of 20% off, and I'll show you how to use that. So if you go here, so I'll start from beginning here. So let's say this is Vedantu.com. You go to courses, you go to Olympiad. So courses Olympiad, then full physics mastery 2025 modules 2, 3, 4, 5 plus module 1 recording. You're getting that for free, by the way. So click on that, you choose your grade. It shows you the price of 10,000 rupees. 4 times 2,500 is 10,000. Now here is what you do. View all offers. Right here, get 20. Get 20, one word, no spaces. Uppercase, lowercase, doesn't matter. So GET 20, you apply that, and you will see the price reduces to 8,000. There is a link in the description. You can use that also for the coupon, right? Now, obviously, many students have benefited from our Vedantu Olympiad schools. They have been getting silver medals, gold medals, and we have spoken a lot about them. So we are proud of all these students, and I am hoping that one day I will be looking at your pictures here. So with that said, we'll end this session, and I'll be back soon with more such PYQ series and other content. If you're subscribing to that course, paid course, welcome. And if you're not, then still, I mean, please do come to this Vedantu Olympiad School channel. We have a lot of content here. So keep up the high Josh, students. Bye bye. Take care.